Hello guys, what's up? I'm Mohammed Ford back with another video about programming. In today's video, we're gonna be checking out what is binary and how computers use it to operate. So, without further ado, let's jump right into it. So, what is binary? See, binary is basically some sort of way of showing numbers. So, we use binary in our everyday life to show numbers. It's basically base 10, which means that every 10 is going to be one block. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on. So, that's basically how we use numbers, and that's basically the logical way of doing it. Hard for computers to do it since they basically use electricity for operating. That's really obvious. So there has to be something which can be connected with electricity, and binary is the exact thing that we're looking for. Binary, I think you've heard it. It's basically made out of 0 and 1, and you've definitely seen these pictures of hacker stuff uh, using ones and zeros. And what it basically means is that computers don't use our everyday way of presenting numbers. They basically use binary, which is made out of 1 and 0. You may ask how, and here is how. Computers use electricity, and electricity can be in two states. It can be on or off, which means that it can flow in a wire, or it cannot flow in a wire. So we have two states to represent it. And binary is exactly the same thing. 1 means it's flowing, and 0 means it's not flowing. So that's basically how computers operate. You may ask how computers are actually using this stuff to operate, and that's basically what we're going to check today. But before that, I think that you have to know how they actually represent our everyday life numbers with binary. So here is how. Alright guys, so here is how it works. You may have heard bit, and so basically you have 1 and 0, and we have places like this to put them in, and each one of these is called a bit. So when I, for example, have a number like this is a 1-bit number. Like 2 digits in our everyday life. For example, we say 21 is 2 digits, so it can be like represented as 2-bit, but so every bit is one of these places, which can either be 0 or 1. So the way that we represent number in binary is pretty simple if you pay close attention to it. Computers nowadays use 32 bits or 64. I'm sure you've heard of these. For example, we have a 32-bit version of Windows or 64 version of Windows. But for now, for sake of simplicity, I'm using a 4-bit system to show this to you guys. So we have a 4-bit system, which is what I'm currently drawing, and the point is that each single place represents a value. For example, this represents value 1 in binary, this one represents 2, this one however represents 4, and this one represents 8. And as you can see, every single time that we move from one place to another, the value multiplies by 2. So for example, if I have the binary number like 1011, its value is gonna be 8 plus 0 plus 2 plus 1. We basically have these houses, and if it's on, we use the value, and if it's not on, we don't use the value, as you can see in here. And this number is gonna add up into 11. So you've just learned how binary works. Okay, but you may ask how we actually apply these fundamental stuff to the real world and the physical world. And the point is that we have many things that have two conditions, whether they're on or off. For example, light. Yes, it could be either on or off. And the point is that the real early computers were made out of lights, and they were obviously really big because they were using this inefficient stuff. So as the technology have improved, we use relays to make computers, and they also act as a light, and they can have two positions, whether they're on or they're off. It's like a switch, so whether they allow a current to go through it or whether it doesn't. Now, the problem that we had with them was that they were quite big and like they were chunk like this. And the other point was that they were really inefficient and we had to change them a lot of times. So that wasn't the solution for computer. The solution was transistors. Now, transistors are what we're currently using nowadays for making our computers, and you might not know, but the CPU is basically made out of trillions of transistors, and that's basically the heart of the computer, and that shows how important the transistors are. But we can't just shove some transistors in together and make a computer. It's definitely more complex than that. So we had to develop something to be able to represent some logics, and we made gates. Now we have AND gate, OR gate, and NOT gate, and these are basically the three main gates that we use in computer and computing and programming. So here's how an AND gate works. See, we have two inputs for an AND gate, and what it basically says is that if the first input and the second input were right, we'll have a output. But whether one of them or none of them were true, we won't have a true output and it will be false. And this combination of transistors will represent exactly this. You might want to pause the video and look at it, think about it a little bit to understand it better. Now, an OR gate is very simple as well. What it's basically saying is that we have two inputs. Now, whether one of them were right or both of them were right, we'll have a right output. The only situation where we don't have a true output is when both of them are wrong. And here is the OR gate represented by transistors. And the last one is gonna be the NOT gate. And what it's basically doing is flipping what the input is. So for example, if you have a true input, the output is going to be false. If it's, for example, a false input, we'll have a true input. And this is the only gate that uses only one. Now that we have these kind of gates, we can do some mathematical logics.
Like adding stuff, subtracting stuff, multiplying stuff, and dividing stuff.
For example, this is the circuit that is in your laptop or phone CPU right now, and it's basically using that to add two binary numbers together. Now you might think, okay, with all these, but how, for example, when you move your mouse, the FPS game that you're playing on your laptop moves as well. Before I try to explain that to you, first you have to know how programming works. So in programming, you write some code and there's a compiler which executes that code and try to turn that kind of code into binary stuff so the computer can understand them. The thing that does this for us is called a compiler. Now, for example, when you write something in Python, the compiler of the Python will turn that code that you've written into assembly language. Now, assembly language is also a language, programming language that have been invented a while ago. And then the compiler of the assembly language, which is called assembler, compiles that code and turns that into pure binary. And now our computer can execute it for us. So the code is gonna get into our CPU and our CPU will understand it since it's some signals in the wires, turning some transistors on and off, opening some gates, and transferring some data, and we'll have a game. So when you move your mouse, a signal is sent through your mouse to the computer telling that the mouse have moved by this far to this position. Now that signal is going to go to your CPU, and when you're running a game, part of your CPU is dedicated to that game. So that signal goes into that game, that is special part of the CPU. Now, in that special part, a compiler is compiling the code that a programmer have already written to execute that game. So that signal goes into the compiler, and the compiler looks at it and says that,
So the programmer that have written me told me that when you get this signal, move the picture to this place. So
it will try to move that picture, for example, to another place. And the way that it actually does it is pretty simple. It just creates some special signals so that it goes to the GPU and to the graphic card, and it will change what you're currently seeing. So you just move. See, it's that pretty simple. So tomorrow I want you to make a computer from zero by using only transistors, and I want to play Call of Duty in it. Good luck! Okay guys, this is the end of the video. It was really fun for me to make this video, and I hope by now you have some rough idea about what binary is and how computers actually operate. So thanks for watching and have a nice day!